Let's demonstrate the ambiguous case for the law of sines. First of all, we have a triangle here. We have both angle A to be 50, and I'm going to start with side A being 5. Well, if we start to solve this problem, again we put the 5 over the sine of 50, 7 over the sine of b, and then proceed to solve for b. As you type in that last expression into your calculator, you'll find that b does not exist. We have a calculator error. Well, your calculator is trying to fondly say that your triangle does not exist. Case 1, we possibly have no triangles. But what if instead of A being 5, what if A was 6? Well, in that case, again we put in our calculator, putting the 6 in place of where the 5 was just a moment ago. And if we try to find the inverse of that calculation, we find that b equals 63.34. Well, if b equals 63.34, we also have to take into the account that in the inverse sine function, it's only going to give us the acute angle. So it could possibly be the supplement of that. Again, sine of 30 is the same as sine of 150. Sine of 10 is the same as sine of 170. So therefore, we should be thinking not only of the b being 63.34, but possibly the b, and I'll call this b2, being the supplement of that, or 116.66. Now, the way I like to look at this problem is, let's say what if? Let's say that possibility that b is indeed 116.6. We already know that a was 50. So let's create a budget problem here. Do I have enough to make the angles go around on my triangle? Again, the triangle angle should add up to 180. So when I add 116.66 to 50, is there a remaining amount to be a triangle? And in this case, there is, 13.34. Therefore, we have a second triangle. Using the law of sines, we can find and solve those missing pieces. Likewise, we seek back to this B1, let's say. Again, A would still have to be 50. We can do the math there and find that missing C for that angle, we'll call that C1, equals 66.66 degrees. Again, this is our first triangle that we can make. And we can solve for both of them. Now, let's go back to the original problem once more. In the original problem, let's say that we change that 6 to now an 8. Well, if I change that 6 to an 8, there is going to be some changes in my calculations as well. Because now I have 8 over sine of 50 equals 7 over sine of b, and so on and so forth, and I can solve for b. And in doing this, I'll find that B is going to equal 42.1. Using the same argument I had just a second ago, if that's my B1, let's say, our B2 is going to be the supplement to that. The supplement of 42.1 would be 137.9. Again, A has to be 50, no choice in that. But if I check my budget here, I'm supposed to add up to 180. I'm already over 180. I'm all over my budget already. I am not going to have a second triangle. So I'm left to go back to this first angle that I came up with and solve my only option, where C is going to end up being 87.9. Now again, I can solve for the missing pieces, but in this case there is only one triangle. There are three cases, possibilities for our triangles. No triangles, two triangles, or one.